awak yang tu lah. Jangan lupa subscribe channel kita, tanda sokongan. Terima kasih. Assalamualaikum and hi everyone. So let's continue examples about subtopic 1.3 under electric potential and electric potential energy. Alright, so let's start. So we have the first example here. Okay, and let's try to read the question first. Okay, so here we have two isolated point charges, Q1 equal to negative 4 microcoulomb. So here, and Q2 is positive 5 microcoulomb and located here, are placed 30 millimeter. Okay, gambar ni tunjuk 50 millimeter. So awak tukarkan ini 50 millimeter. Okay, alright. So determine the total electric potential at point Q, where the position of point Q is 10 millimeter to the right of the second charge. Okay, dekat sini lah. Okay, so kita lukis dulu Q, point Q. So here let's say we have a point. Okay, so let's say this is a point Q, where the distance of Q from Q2 is 10 millimeter. Okay, so here we have 50 millimeter and 10 millimeter. And now we want to determine the electric potential. So always remember, okay, equation for electric potential, okay, yang you kena ingat, V is equal to KQ over R. Okay, dan satu lagi equation that related to potential, electric potential, is delta V is equal to W over Q0, where Q0 is the test charge. Okay, so Q1 dengan Q2 ni, so kita ada ini adalah point charge yang pertama. So ini adalah point charge. Okay, and ini adalah point charge yang kedua. Satu positif, satu lagi adalah negatif, point charge. Okay, so here is negative and this is positive. So sekarang kita nak kira electric potential. Alright, so as usual, kita nak kira electric potential by using equation F equal to KQ over R. So kita nak kira electric potential at point Q here. Okay, so kita guna formula apa? V, okay, electric potential at point Q. Okay, kita ada dua point charge, means that electric potential at point Q, okay, due to charge 1 plus electric potential at point Q due to charge 2. Okay, and always remember charge 1 kita tu adalah negatif. So dalam calculation untuk electric potential, okay, untuk electric potential dalam calculation, okay, please include, okay, the negative sign of the charge. Okay, tapi kalau electric field dan electric force, okay, kita perlu tahu negatif positif tu in order to determine the direction of force or field. Okay, jadi dalam calculation untuk electric force dan electric field tak perlu masuk negative sign of the charge. Tapi untuk electric potential and electric potential energy, we need to consider the negative sign in the calculation. Okay, so now let's substitute in this equation. Okay, KQ1 and R1. Okay, RQ1 is the distance between point Q and charge 1. Okay, plus KQ2 over RQ2. Okay, so kita masukkanlah. Okay, so kita dah boleh kira. So 9 times 10 power of 9 K, we can factorize for K. Okay, and then here saya highlight lah Q1 kita adalah mana Q1? This one. Q1 kita adalah negatif. Okay, so pastikan masukkan negatif dalam calculation. So Q1 is equal to negative 4 exponent negative 6 microcoulomb, and distance antara point Q dan charge 1. Okay, look at here. So we have point Q here and this is charge 1. So 50 plus 10, so dia akan jadi 60 millimeter. Okay, 60 millimeter. Okay, and then plus, okay, Q2. Okay, so Q2 is equal to 5 microcoulomb over the distance between point Q and charge 2. Okay, it is 10. Okay, 10 millimeter. Okay, So potential KQ over R, and the final answer is equal to, okay, cuba you kira. Alright, so after calculation, okay, the answer is equal to 3.9 times 10 power of 6 Newton. Okay, volt. So the unit is volt. Okay, this one is electric potential. So the answer is 3.9 power of 6 volt. Alright, so make sure you kira betul-betul lah. Okay, tolong check dan tekan calculator lah, tahu saya salah kira ke. Okay. Alright, so next, look at here, we stayed in question number 1. Okay, for the second part, so let's read the question first. Calculate the work done. Calculate the work done required to bring a charge. So this is referring to the test charge, 5 microcoulomb from infinity to a point, where that point is 0.8 meter from another charge. So this is the point charge of 40 microcoulomb. Okay, so let's say here we have a point charge and this is positive and 40 microcoulomb. So Q, alright, and the distance between the charge and the point, here we have a point P, let's say P. So the distance between them is 0.8 meter. Okay, so let's say we have a test charge. Alright, so let's say this is the test charge. Okay, and then we want to bring the test charge from infinity to this point. Alright, so we can calculate as usual. Let's write the equation first. Okay, so we have V is equal to KQ over R, or another equation that related to potential and work. Alright, kita nak kira work kan? Work done is equal to delta V, okay, equal to W over Q. Alright, so now we want to calculate W here. Okay, so we can write W. Okay, so W is equal to Q times delta V, where delta V is the electric potential difference, okay, between infinity and point tadi. Okay, so kita boleh tulislah dekat sini Q. Okay, we want to bring, okay, the charge from infinity. So initially position dia adalah infinity and final adalah at point P. So VP minus V infinity. Okay, so bila kita substitute dalam equation, so kita ada KQ over RP. RP is the distance, okay, distance daripada point P, okay, to the point charge. Okay, P dengan point charge ni adalah 0.8 minus, okay, KQ over R infinity. Okay, so bagi dengan infinity, okay, ini akan jadi kosong lah. Okay, sini akan jadi kosong. Okay, apa-apa nombor bagi infinity kan kosong kan? Okay, so kira dulu, substitute all the values. So here we have 5. Okay, kita kira dulu Q kita berapa? 5 kan? 5 microcoulomb. Okay, times K Q over R. So K Q over R. RP is 0.8. And finally, we can have the answer, work done required to bring a test charge Q equal to 5 microcoulomb daripada infinity to 0.8 meter from the point charge is equal to 2.25 joule. Alright, so this is the answer for example 1, question number 2. Okay, okay, question number 2. So here we have 3 charges. Alright, and calculate the electric potential at the midpoint of the base. So kita ada P dekat sini, taking Q is equal to 7 microcoulomb. Alright, so this is point P here. So bila saya nampak soalan macam ni, kita nak kira electric potential at point P. But before we start, so let's calculate here what is the distance between, okay, Q1, kita namakanlah ni Q1, and this one is Q2, and this is Q3. Okay, tengok dekat sini, Q2 kita adalah negatif. Dalam calculation, jangan lupa masukkan negative sign. Okay, so jarak point P, Okay, jarak point P dengan Q1 kita boleh kira. Since kita dah tahu ini 2 meter, so means that hypotenuse of this triangle here minus 1 here, 4 squared minus 1 squared, take the square root and then you have this one. Okay, so the answer here, okay, the distance between point P and charge 1 is 3.87 cm. Tolong check Okay, kadang-kadang saya tersilap kira, you boleh betulkan saya. Okay, so now we have 3 charges, means that the net electric potential at point P, Vp is equal to Vp due to first charge, okay, and Vp due to second charge, and electric potential due to the third charge. Okay, electric potential dengan electric potential energy tidak perlu lukis direction, tetapi dalam calculation masukkan negative sign. Okay, so now let's try to substitute. Okay, we have KQ1 over RP1. Kenapa saya tulis RP1? Okay, saya suka tulis macam ini supaya saya tahu, oh, RP1 ni jarak antara point P dengan charge 1. Okay, supaya kita tak salah substitute nanti. Okay, plus KQ2 over RP2 plus KQ3 over RP3. Okay, so kita masukkan. Tengok kat situ. Okay, so now we can substitute. Jangan lupa tadi Q1 dengan Q2 tadi ada negative sign. So, Q2 dengan Q3 ada negative sign. So, you masukkan nilai dia. Okay, saya factorizekan K. So, 9 times 10 power of 9. And then here we have Q1, 7, 7, positive 7 microcoulomb. Okay, over the distance between 3.87 cm tukar kepada meter, 0.0387. Plus Q2 is negative 7 microcoulomb. Over distance between point P and Q2 is 1 cm, should be 0.01 meter. Okay, so negative dekat sini. Plus, so here we have another negative. Over 0.01. Okay, and then we can write, this one. Okay, 9 times 10 power of 9, and then here is negative 1.219 exponent 3, negative 3 saya dapat. So final answer, okay, the electric potential at point P saya kira dan saya dapat negative 1.1 times 10 power of 7 volt. Okay, so finish example number 2. Alright, example number 3. What is the electric potential at point A, where the point A is 1 meter from each of two 30 nanocoulomb point charges. Okay, maknanya kita ada 2 charge dekat sini. Jom kita buat A. Okay, lukis dulu. So, kita ada positive charge here. So, Q1 is 30 microcoulomb. And then we have second charge. Okay, sama jugalah, positive 30 microcoulomb. And the distance between them, soalan tak bagi kan? Tapi soalan kata, kita ada satu point di mana, kat sinilah, point A jaraknya 1 meter dari Q1 dan 1 meter daripada Q2. So, kita tahu dia duduk tengah-tengah lah. Okay, kena pandai lukis ni. So, kita nak kira electric potential at point A. So, kita akan ada VA is equal to VA1 plus VA2. Alright. So, kita substitute saja. VA1 is the potential at point A due to charge 1. So, KQ1 and the distance between point A and charge 1 plus KQ2 over RA2. Okay. So, we can substitute. Q1 dan Q2 dua-dua positif, so tak ada masalah lah. Okay, so distance R pun dalam meter, so we can just substitute. Ini saya factorizekan. Q1, okay, nanocoulomb bukan micro, baca soalan betul-betul. So 1 meter plus another Q2. Okay, and then finally VA saya dapat 540 and the unit is volt. Alright, so jangan salah Okay, and then finish this one. B, calculate the work done to bring a charge. Okay, to bring a test charge negative 10 microcoulomb from very far away to the point A. Sama macam soalan tadi lah. Kita dah buat tadi kan sebelum ni. Okay. Sama macam soalan nombor 2 tadi tak silap. Okay. So based on this equation, okay, W over Q, okay, so we can write W is equal to Q delta V. Delta V tu the potential difference, okay, kita nak bawa daripada mana ke mana, kan? So kita kira lah. Dia daripada far away, so we consider infinity to point A tadi. Okay, so Q final, okay, VA minus V infinity. Okay, so ini adalah V final minus V initial. Okay, so masukkan nilai dia. So yang ni kosong lah. Yang ni V infinity kosong. So Q is negative 10 times 10 power of negative 6. VA tadi kita dah kira 540. Therefore, W is equal to negative 5.4. Exponent negative 3, you can tulis millijoule. Okay, ataupun tulislah W negative 5.4 milli times 10 power of negative 3 joule. Okay, so finish example number 3. Alright, example number 4. So here we have a particle with a charge of 5 millicoulomb move from point A to Y in an electric field. Okay, so yeah, its kinetic energy increases by 1.5 joule. Okay, so we have a test charge. Okay, so here we have Q is equal to 5 exponent negative 3 coulomb. So the question states that, okay, the kinetic energy increases by 1.5 joule. So the question states here that the kinetic energy increases by 1.5 joule. Okay, so daripada sini kita tahu kita ada energy dia. So means that 1.5 joule work is done. Okay, so W is equal to 1.5 joule. Okay, so daripada maklumat dia bagi tu kita boleh relate kan. Therefore, we want to calculate the potential difference between point X and point Y. So delta V is equal to W over Q. Therefore, okay, substitute sajalah kan. 1.5 over 5 exponent negative 3 and you dapat jawapan 300 volt. Okay, so finish example number 4. Alright. Example number 5. So here we have 3 points charges. Okay, so we have Q1, Q2 and Q3. Okay, dekat sini kita nampak Q3 kita adalah negative sign. Alright, calculate the electric potential energy of the system. Okay, calculate the electric potential energy of the system. Okay, so we want to calculate U of the system means that, okay, U of the system, okay, means that U equal to U between 1 and 2 plus U between 1 and 3, plus U between 2 and 3. Dia macam tu kalau sebut energy of the system. Okay, maknanya kita ada 3, so kena kira ke semuanya. Okay, pairing-pairingkan semuanya. Okay, so formula U jangan lupa KQ Q over R. Okay. So now we can just substitute U12 is the electric potential energy between charge 1 and charge 2. So we can substitute here based on the formula should be KQ1 Q2 over R12 plus KQ1 Q3 over R13 plus KQ2 Q3 over R23. Okay, so remember Q3 tu negatif, dalam calculation jangan lupa masukkan negatif. Okay, so we can just substitute all the values here. Q1 kita dah ada 4, masukkan panjang pula ni kan. Banyak nilai nak kena consider. Q2 is positive 3 microcoulomb over the distance between the distance between Q1 and Q2, R12 merujuk kepada ini 5 cm, tukarkan kepada meter. Okay, plus Q1 and Q3. Q1 is 4 again, 4 micro. Okay, Q3 is negative 5 micro. over the distance between 1 and 3 is 10 centimeter. Okay, so saya suka highlightkan negatif ni, janganlah tertinggal. Okay, plus Q2 and Q3. So Q2 is 3 and Q3 is negative over jarak antara 2 and 3 is 5 centimeter. Kan? So negatif. Tekanlah kalkulator ni. Jangan salah tekan kalkulator. Okay, finally saya dapat jawapan negative 2.34 joule. Sila check betul tak saya kira dan awak kira. Okay, so finish example number 5. Alright, so now kita dah sampai example yang terakhir tapi ada 3 anak soalan. Okay, panjang juga example ni. So let's try. In figure above, so now let's try. So in the figure we have charge at A, okay, is 200 picocoulomb. So here picocoulomb, and while the charge at B is negative 100 picocoulomb. Okay, so means that we have here is positive charge and here is negative charge. Alright, so calculate the electric potentials at point C and D. Okay, kita ada 2 point, kita buat yang pertama. Kita nak selesaikan at point C. So maknanya kita tengok jarak antara point C dengan A, charge dekat A, dan jarak antara point C dengan charge dekat B. Okay, so saya suka tulis Q1 dekat A, Q2 namakan charge dia Q2 dekat B. Supaya kita masuk nilai nanti tak salah. Okay, so kita mulakan dengan A. So kita nak cari dekat C, so ada 2 saja charge. So VC1 plus VC2. Okay, so masukkan saja formula. C1 referring to charge 1. RC1 is the distance between point C and charge 1. Jarak dia adalah 80 cm. Okay, yang ni pula B dengan C 20 cm. Okay, so tengok betul-betul, jangan salah substitute dan jangan salah tekan calculator. Boleh Okay, so saya masukkan nilai dia 9 exponent 9. Okay, so Q1 is 200. Pico is negative 12, right? RC1 is 80 cm. Tukarkan kepada meter. And then plus, okay, so plus Q2 negative 100. Negative 100 pico. Okay, jarak antara C dengan point B 20 cm. Okay, and finally you dapat jawapan negative 2.25 volt. Okay, 2.25 volt. So VC dah settle, so kita buat pula VD. So VD is equal to VD1 plus VD2. Okay, kita akan refer dekat point yang warna orange ni. Okay, so jarak antara D dengan A 20 cm, jarak antara D dengan B 80 cm. So bila masuk nilai tu, masukkan betul-betul. Dan pastikan kita punya Q2 ni ada negatif ni sebab negative charge. So dalam calculation jangan terlupa. Okay, ini awak tulis lagi sekali lah. Masukkan nilai K, jangan lupa. Okay, tulis satu-satu, practice sebab you baru nak belajar kan. So Q1 200 pico bahagi dengan RD1 20 cm plus Q2 is negative 100. Okay, negative 100 picocoulomb bahagi dengan jarak antara point D dengan charge yang kedua adalah 80 cm. Okay, so finally you akan dapat VD is equal to 7.88 volt. Okay, so A settle. And then B, if charge of positive 500 microcoulomb is placed at point C and D. Maknanya charge tu sama ada kita nak letak dekat point C ataupun D. Dia suruh buat dua jugalah, dua kerja. Calculate the electric potential energy at point C and D. Okay, kita buat point C dulu. Lepas tu kita buat dekat point D. Okay, so kita, okay, so kita cuba, kenapa ni? Sekejap Okay, so let's try to solve for B. Okay, so here we have positive charge Q1 tadi kita ada, and then kita ada negative charge Q2. Okay, so let's say point C kat sini tadi kan, betul tak, point C, and then we put a charge, okay, Q3. Okay, so soalan bagi tahu tadi Q3 is equal to 500 microcoulomb. Okay, and then the distance between Q3 and Q1 is 80 centimeter, and then this one should be 20 centimeter. Okay, refer balik pada soalan tadi. Okay, ni saya lukis semula. Alright, so kita start dengan C. If Q3 at C, okay, so we want to calculate U. So ada 3 charge lah dekat situ. So sini satu lagi adalah positive charge. Kan, positive charge. Sama macam kita kira tadi. U13 plus U12 plus U23. Sebab ada 3 kan. So kita boleh selesaikan. Formula UK Q1 Q3 antara U13 R13. Okay, jangan squared pula. Okay, kalau U squared dah jadi force punya equation. Okay. Plus KQ2 Q3 over R23. Boleh Okay, so substitute all the values. Okay, K tu saya letak kat depan. Banyak ni kita nak kira. Q1 is given 200 pico. Okay, 500 micro Q3. Soalan dah bagi. Jarak antara Q3 and charge 1 80 cm. Okay. Plus apa lagi tu? Q1 pula. Q1 200 pico. Q2 berapa tadi? Okay, 100. Negative 100. Negative jangan tertinggal. Okay, so negative 100 here. Bahagi jarak antara charge 1 and charge 2 adalah 100 cm. Dan tambah juga, apa dia kat situ? Q2. Okay, negatif lagi sekali. 100 picocoulomb. Q2 and Q3 is 500 microcoulomb over this one should be distance between 2 and 3 20 centimeter. Okay, so negatif jangan tertinggal. Okay, sekarang you tekan calculator slowly and steady. You see you akan dapat negative 1.13 times 10 power of negative 3 joule. Unit untuk energy jangan tersilap. Okay, so this is the answer for U at C. And then kita nak kira pula yang kedua. Okay, if Q3 at point D. Okay, ini tadi C, yang bawah tu adalah D. Okay, sama jugalah kita akan buat benda yang sama. Cumanya kalau kita lukis semula, okay, kita bandingkan. Kalau D tadi, jarak dia dengan Q1, okay, adalah 20 cm. Ini point D. Point D lah. Kita letak Q3. And then jarak Q3 dengan Q2 is 80 cm. Okay. So sama juga kita nak kira U at D, U12 plus U13 plus U23. Okay. So we can just substitute. Sama macam tadi. Cumanya bezanya apa? Jarak ini. Jarak antara Q1 dengan Q3 ni. Okay. Q1 ni 20 cm. Kalau tadi sini 80 cm. Okay. So sekarang yang ini dah jadi 20 cm, yang ini jadi 80 cm. Yang lain sama. Yang tengah ni samalah, jarak antara 1 dengan 3 masih sama. Jarak antara 1 dengan 3 ni masih sama 100 cm. Okay, cuma yang saya bulatkan dengan warna kuning ini saja tukar. Sini jadi 20 cm, this one 80 cm. Okay, so kalau kita tulis semula, panjang ni nak tulis. Okay, so UD is equal to 9 exponent 9 plus Q1, okay, this one should be bracket. Q1, Q3, okay, Sama, you salin je balik yang kat atas tu tadi. Q1, Q3. Okay, the distance between them is 20 cm. Okay, yang tengah ni dia sama. Jarak antara 1 dengan 2 samalah 100 cm. Okay, charge jangan lupa negatif. Okay. Last sekali adalah between 2 and 3. 500 micro, tak muat tepi ni. Over, this one should be 80 Okay, tengok beza dia. Okay. Ni dengan ni, ni dengan ni. So ada beza jarak dia tu yang beza, point C dengan point D. Okay, you tekan kalkulator elok-elok, you dapat 3.94 exponent negative 3 joule. Unit jangan salah. Alright. And then next question. Okay, question mana tadi? See the change in potential energy between point C and point D. Okay, the change in potential energy between point C and point D. So the change delta U between C and D is equal to UC minus UD. Okay, so saya masukkan nilai yang kita dah kira for UC, and then UD kita dapat positif tadi. Okay, masukkan nilai. Finally, you will have your answer here, negative 5.07 exponent negative 3 joule. Alright, so this is the answer. Okay, so we have finished discuss all the questions related to 1.3. So see you in the next video. Okay, kalau you nak lagi soalan, you boleh tengok video sesi lepas. Okay, di video ini yang saya letakkan dekat link dekat atas ini. And at the end of this video, saya juga linkkan satu video berkaitan dengan example electric potential dan electric potential energy. Okay, so thank you. Jumpa lagi. Assalamualaikum. Bye-bye.